Okay, so we're doing mole calculations, dynamic study module. How many atoms, of H in 2.8 moles of N2H4? Okay, so you have 2.8 moles of this molecule, right? So let me ask you this. If you have 1 mole of this molecule, how many moles of hydrogens would you have? Not 2, but 4, right? So if you have 2.8 moles of it, you would have 4 times that, right? See, for every molecule, which is the package, right, you have 4 hydrogens. Okay?
For every molecule, you have
2 nitrogens and 4 hydrogens, yeah. And so we're looking at hydrogen, H. And so 2.8 moles would mean you have how many moles of hydrogen? Not 4, but times 4, right? So you take 2.8 times 4. What would that be? So you have 11.2 moles of the hydrogens. Okay. Now we don't want moles for our answer, do we? We want atoms. So how many, remember moles are a package of something, right? Okay, so how many individual items are in a mole? That is? You got it, Avogadro's number, right? 6.02 times 10 to the 23rd. Okay, 6.02 times 10 to the 23rd, right? So that means there's 6.02 times 10 to the 23rd atoms in 1 mole, right? Okay. Notice that you want to get rid of moles and you want to get into atoms, right?
Yes, I have to multiply 11 times 11.2.
Got it. So 11.2 moles of hydrogen times 6.02 times 10 to the 23rd atoms of hydrogen per every 1 mole. And that will cancel out moles and leave you in atoms. And you should get like, yep. Nope. You said 60? 67. Yeah, 67. So if you were to rewrite that,
7.64 times 10 to the 24.
no, you had 67. So that should have been 6.7 times 10 to the 21st, right?
To the 24.
Yeah. Okay, I heard 7 something. Okay. And that should do it. Not that bad, right? It's just understanding packages inside of packages. And the analogy I kept using in class was moles is like a package of a dozen, right? And then if you had candy bars as your dozen candy bars, well, inside of those are the individual twigs, right?
Mm-hmm. Can I try to do that by
Sure.
myself? This one.
Go for it.